We now begin studying relations and functions by looking at relations. So let A and B be sets. A relation from A to B is a subset of A cross B. Given an ordered pair XY that is in A cross B, we say that it is related to Y by R, which is written as XRY if and only if XY is in R. This set A is called the domain of R, and the set B is called the codomain of R. So let A be the set of 1, 2, let B be the set of 1, 2, 3. Define a relation R from A to B as follows. Given any xy in A cross B, xy is in R if and only if x minus y over 2 is an integer. We will explicitly state what R is, and then state the domain and codomain of R. So first, let's state R. So remember, we're going from A to B. So x will be 1, y will be 1 first. So 1 minus 0 over 2, that is an integer. So 1, 1 is in R. Now let's look. X is still 1, but now y is 2. 1 minus 2 is negative 1, but negative 1/2 is not an integer. So 1, 2 is not in R. Now 1 minus 3, negative 2 over 2 is negative 1. That is an integer. So 1, 3 is in R. Now we look 2, 1. 2 minus 1 is 1 over 2 is a half. That's not an integer. 2 minus 2 is 0 over 2 is 0. That is an integer. So 2, 2 would be in R. 2 minus 3 is negative 1 over 2 is negative a half. That is not an integer. So this would be R. The domain is A, so it's the set 1, 2. The codomain is B, and so that is the set 1, 2, 3. Now suppose that R is a relation from a set A to a set B. The arrow diagram for R is obtained as follows. Represent the elements of A as points in one region, and the elements of B as points in another region. Then for each x in A and y in B, we draw an arrow from x to y if and only if x is related to y. So we're going to let A be the set 1, 2, 3. We will let B be the set 1, 3, 5, and define relation S and T from A to B as follows. X, S, Y, if and only if x is less than y, and T is the set of 2, 1 and 2, 5. We'll draw arrow diagrams with both of these. So let's start with S. So we draw a region to represent A, draw a region to represent B. So 1, 2, 3, those are the elements of A. 1, 3, and 5 are the elements of B. So now we just have to draw arrows from all of the x elements that are related to the y element. So x, s, y, if and only if x is less than y. Well, 1 is not less than 1, so there's no arrow. 1 is less than 3, so we can draw an arrow. And 1 is less than 5, so we can draw an arrow to 5. 2 is not less than 1, 2 is less than 3, so we can draw an arrow to 3. And 2 is also less than 5, and so we can draw an arrow to 5. 3 is not less than 1, 3 is not less than 3, but 3 is less than 5, so we can draw an arrow to 5. And this would be our arrow diagram for S. Now for T, we're going to use the same two sets. So here's our region for A. Let's say here's our region for B. 1, 2, 3, and then 1, 3, and 5. So 2 is related to 1, and 2 is related to 5. So this would be our arrow diagram for T. Now define a relation E from the set of integers to the set of integers as follows. N is related to n by E if and only if m minus n is even. We will go ahead and prove that if n is any odd integer, then n is related to 1 by E. So let n be odd. Then, by definition, we know there must be some integer q such that n is 2q plus 1. Well, now let's take a look at n minus 1. This would be equal to 2q plus 1 minus 1, which is equal to 2q. Well, this means that n minus 1 is even by definition. Well, that would mean that n and 1 are related by E. That is what we wanted, and so the proof is complete. Now, let X be the set ABC. Define a relation S from the power set of X to the power set of X as follows. For all sets A and B in power set of X, A is related to B by S if and only if A has at least as many elements as B. So we have four questions here we want to answer. So is the set AB related to the set BS by S? Well, this has 2 elements. This has 2 elements. Well, then this set would have at least as many elements as this set. So yes, those 2 sets are related. Is the set related to the empty set? Well, the set A has 1 element, the empty set has 0, and 1 is greater than or equal to 0. So yes, the set A is related to the empty set. Is the set AB related to the set ABC? No, the set AB has 2 elements, the set ABC has 3. 2 is not greater than or equal to 3, so no, these 2 sets are not related. Is the set C related to the set A? They both have 1 element, so yes, they are related. Let R be a relation defined from A to B. The inverse relation, denoted R to the minus 1, read R inverse, from B to A, is the set of ordered pairs Yx in B cross A, such that Xy is in R. The inverse relation, all you do is you take the ordered pairs in R and flip the order. That is R inverse. So we're going to let A be the set 2, 3, 4. We'll let B be the set 2, 6A. And we'll define a relation R from A to B as X is related to Y if and only if X divides Y. We will explicitly state R and then explicitly state R inverse. So R. So 2 does divide 2 does divide 6, and 2 does divide 8. 3 does not divide 2. 3 does divide 6, but 3 does not divide 8. 4 does not divide 2. 4 does not divide 6, but 4 does divide 8. And so this would be our R. So our inverse, all we do is we take each ordered pair and flip the order. So we have 2, 2, 6, 2, 8, 2, 6, 3, and 4, 8, 4. Sorry, 8, 4. Now in words, R is essentially saying X is related to Y if and only if X is a factor of Y. Our inverse is saying that Y is related to X by our inverse if and only if Y is a multiple of X. So another way of defining relations is from one set to itself, right? We've seen that. Where was it? It was, this is an example, right, of a relation that is from a set to itself. In which case, we'll simply say that R is a relation on the set A, or R is a relation on A. So this means that R is a relation from A to itself. Now, when a relation is defined on a set, we can modify the arrow diagram of the relation into what is known as a directed graph. So instead of representing the set as two separate sets of points, we represent it only once and draw an arrow from each point to each related point. And we'll look at that with this relation. So the set A is a set of 3, 4, 5, 6, 7, 8. We'll define a relation R on A as follows. For every x and y in A, x is related to y if and only if 2 divides x minus y. So we'll go ahead and draw the directed graph. So we're going to draw how many points? 1, 2, 3, 4, 5, 6. So we'll draw 6 points. 1, 2, 3, 4, 5, and 6. All right. That should be good. So this we're going to call 3. This we'll call 4. This one we'll call 5. We'll call this 6. We'll call that 7. And then we'll call that 8. So we need to draw a line from each to the points that it's related to. So 3 minus 3 is 0, and 2 does divide 0. So 3 is related to 3. 3 minus 4 is 1. 3 minus 5 is 2. That is divisible by 2. 3 minus 6 is 3. 3 minus 7 is 4. That is divisible by 2. 3 minus 8 is 5. So 4 minus 4 is 0. That is divisible by 2. 4 minus 3 is 1. That is not. 4 minus 5 is 1. That is not. 4 minus 6, 2. That is. 4 minus 7 is not. But 4 minus 8 is. All right, so 5 minus 3, that is divisible by 2. 5 minus 4 is not. 5 minus 5 is. 5 minus 6 is not. 5 minus 7 is, and 5 minus 8 is not. So 6 minus 3 is not, but 6 minus 4 is. 6 minus 5 is, but 6 minus 6 is. 6 minus 7 is not, but 6 minus 8 is. 7 minus 3 is divisible by 2. 7 minus 4 is not. 7 minus 5 is divisible by 2. 7 minus 6 is not. 7 minus 7 is, but 7 minus 8 is not. 8 minus 3 is not, but 8 minus 4 is. 8 minus 5 isn't, but 8 minus 6 is. 8 minus 7 isn't, but 8 minus 8 is. And then this would be our directed graph. So that is it for an introduction to relations. In the next video, you're going to look at some properties of relations.